Okay, let's go through these Trigo questions. So we have this figure, right? Then they ask us to find angle ABC. Okay, so first, I recognize there's one right angle triangle, meaning that I can actually use okay, don't need Tuakaso because we got this thing, we got A, we got B, right? I can actually find C square or this thing. So let's call this A, let's call this B, let's call this C. So A square plus B square equal to C square. So A square is 90 square plus B square 200 square equal to C square. So C square is equal to, let's see, 200 square. So it's about 48100. So C is equal to square root 48100. So it's roughly 219.317. Okay. So the next thing, okay, since I know what is this AC already, I can simply just use something that we learned, the rule that we learned in Trigo. So okay, so I just put down this first. Okay, so this is the angle, right? So 240, 350, and of course 219.317. So how do I find the angle? So if we are given three sides, obviously we must use something called the cosine rule, right? So A square. Okay, so let's call this B A. Let's call this side A. Of course, this side B. This is side C. So A square equal to B square plus C square minus 2BC cosine A. So it's sub in. So for example, let's sub in together. So 219.317 square equal to 240 square plus 350 square minus 240 350 cosine A. Okay. So okay, let's do the calculation. So for okay, let's calculate this first. So you this thing, calculate this, then this one and this one you move to the left hand side. So it's okay, let's so it's here. 317 square minus 240 square minus 350 square is equal to negative 240 350 cosine A. Okay, let's continue. 219. Okay, so you get roughly negative 132,000.0535. So this thing, you also move to the left hand side. But when you move these three terms to the left hand side, it's actually divide. Because this one, this light blue color is multiplied by cosine. So multiplied, you move, become divide already. So this whole thing divide by negative 240 350 equal to cosine A. Then you just do it one by one. So don't sub everything inside the calculator. Because you sub everything, I think high chance we will make a lot of careless mistake. So divide by negative 2 350. Okay, so it's about 0.785714,604. So you just need to do a cosine inverse of cosine inverse A. I mean cosine inverse 0.785714,604. So cosine inverse 04. So it's about 38.2 degree. So that is for part A. Okay, so let's go to part B. A model airplane 20 meters above the ground flies from A to C. So A to C is this part. So find the angle, largest angle of elevation of the aeroplane right from point D. So okay, I look at here. So if every time you see a largest angle of elevation, is as good as saying if you are standing at point D, the airplane should be at the shortest distance from your point to its point. So for example, okay, you go here. Okay, so this part D. So AC is here, right? Okay, so of course, you think of it as the airplane is above the AC. So when the airplane is right here, Now, of course, it's not at the ground AC. It's above the ground AC. You are right here. So this thing must be the shortest distance. Such that when you look up to the airplane, it should be the largest angle of elevation. Right? Okay, so let's continue. So 20 meter. Okay, so you look at the side view. So for example, you look at the side view, right? So at the side view, it will look something like this. So imagine that this point D. Okay, let's call this point maybe X lah. Let's call this point X. The base is point X. The airplane is here. So this airplane. Just draw something here. Okay. So the angle of elevation is like this. So this angle right here, right? Okay, I call this angle theta. Okay, so this is 20 meter. The next thing that we need to find is actually to find what is our dx. Because I need dx, right? Then after that I can use Tuakaso to find already. Okay, so how do I find dx? So this way I need to use a bit of the area, right? So apparently we are right angle triangle. I can actually use half times base times height. So this is area of ACD, right? Is equal to half 290. So you multiply, right? You should get 100 times 90, 90, 1, 2. So the area of this triangle is 9,000. I can also say I can actually use AC, right? Multiply by this height to get the same 9,000 meter square, or the area lah. So I know this whole thing here is 219. So I simply use that. So 219, right? Okay, so this AC is 219. 219.317 times H, right? Half times. Okay, so let's do a calculation. So H 9,000.5 divided by 219. So it's about, okay, so this H, the so-called the shortest distance, right, is roughly 82.1 meter. And just recognize this H is the dx. It's actually this thing right here. Okay, so this is 82.1 meter. And then the last step, use Tuakaso. So tan theta is equal to oppo over adjacent. So your theta is equal to tan inverse 20 divided by 82.1. Yeah, so you should get an angle of elevation of 13.7 degree. So just make sure for angle wise, you should put in terms of 1 dB. Yeah, so for the part B, you will need to do a bit of visualization. So yeah, so maybe I just guide you through again. For the, okay, especially for the part B, okay, part B, the aeroplane is on top. So in order to have the greatest angle of elevation, the point where you stand, which is point D, right, must be the shortest distance to the line AC. Then after that, to visualize, you need to see the side view. So imagine this is you, right? This is the I. So this is the aeroplane. Then you look up. That should be the greatest angle of elevation, right?